Hello everyone, welcome to Project Sadgorang. Today we are going to do another project which is node placement optimization using chicken swarm optimization. In this, what we have to do is we have to place the sensor nodes in a 2D space using chicken swarm optimization algorithm. The area which is given to us is a marshland, so there will be uneven land and water areas. So it is given that 50% of the nodes are water nodes and rest are the land nodes. There are land node parameters, underwater node parameters, number of clusters which are present, and the node topology. Here, node topology can be anything. I'm taking tree. You can try with bus and star topology too, and do share the results if you do that. So let's start coding. First, we will import all the necessary libraries. So import numpy as np, import matplotlib.pyplot as plt. Then we will define all the constants. So here are the constants. Number of nodes, you can take any number of nodes. I am taking 50. Number of underwater nodes, land nodes, number of clusters, here you can change them, and number of dimensions. Here we are working in two dimensional space, that's why the dimension is 2. So now we will define the energy parameters. Here are the energy parameters. So underwater recharge, the all the parameters which are given here: the recharge, average consumption, and on communication consumption for both underwater nodes and the land nodes. Now we will define the tree topology. So here is the tree topology. Now why we are using tree topology? Because in the question we are given that we have to use tree topology. You can use any other topology. It will work with every topology, star, bus, and if you are thinking some new topology, it will work with that too. So what are we doing? We are assigning the number of nodes and the number of clusters as parameter to the generate tree topology function, and by the number of clusters, it is dividing the number of nodes into random shuffle patterns. Here, np.random.shuffle is doing the job. So now we will code the objective function. What objective function do is that it tells chicken swarm optimization algorithm that you have to optimize based on certain objective, means what the user wants. This objective function, you can say, is the heart of a chicken swarm optimization algorithm, and writing this correctly is like winning half of the battle with chicken swarm optimization algorithm. So be very very careful when you are writing chicken swarm optimization or any other optimization algorithms objective function, because if the objective function is wrong, no matter what you write, it will produce wrong results. Now in this, what we want is that the system should consume least amount of energy so that system can work for most amount of time. Because what happens with the sensor nodes is that they're very resource scarce device, like there is low memory, there is low power. So we want that we have to use least amount of it so that they can work for long time, because there is some cost factor too, that if you are to replace the nodes regularly, the cost will shoot up. So we have to take care of that. You can use any other parameter when you are writing the objective function. I am taking total energy consumed, so let's write it. So here you can see I'm using total energy consumption as a parameter, and I'm optimizing based on this parameter. So what it is doing is it is checking for underwater nodes and for the land nodes and calculating their energy consumption based on this distance. So it is giving us the distance. Here you can see, then if there are underwater nodes, then we have to minus underwater recharge, because this energy is not consumed, it is added. And if we are on land, then the node energy consumption will be minus is on land solar panel recharge. So now let's implement a node placement optimization using chicken swarm optimization algorithm. So here's the code. Here you can see we have passed the objective function as a parameter to the node placement optimization code. So here you can see we have number of nodes, number of clusters, dimensions, and how many times we want to run this function. Because what happens with these type of algorithms is that in first pass we might not get the best solution, so we try with certain number of iterations to find the best solution. Here you can see one of the best solution, or in optimization algorithms, best fitness is a keyword used. So best fitness is given by objective function, and then we are returning the best cluster head values, best fitness values, and the node positions also. Now let's code our last function, which is the plotting function. It's just for the visualization of our solution. So here's the code. It is a very simple code. It's just like we are plotting a scatter plot, and we are giving some title, x label, y label, and we are showing what we are plotting. Now let's use the functions which we have written, because we have to use the functions. So here we are completing our code. I am defining number of iterations as 100, best cluster heads, best fitness, node positions from the chicken swarm optimization, node placement optimization, tree topology function, and here are the things like I have printed. You can print, you can't print. Just I just printed for my convenience. And here's the plot function. So run it. So here you can see is our solution. Now what will happen is that your scatter plot will be different from my scatter plot, because whenever we run these algorithms we get a different solution. So let me run it again to show you what I mean. Run it again. Here you can see all the cluster heads are on same location, which we don't want. So we will run again. Here you can see the cluster heads are shifting their position, the nodes are shifting their position. So you have to check also when you are applying this in the real world. It's just, you can say, a simulation. So that's all for this video. Thank you very much for watching the video. If you like this video, do subscribe to my channel for more videos, because I'm going to bring more videos on chicken farm optimization applications and on other projects too. So thank you very much for watching the video. Thank you.